All right, let's talk about the future. Specifically, the technology that's already in our pockets and the stuff that might be on our faces sooner than we think. We're going to dive into the incredible promises of this cutting-edge tech, but also some of the, well, hidden problems that come along with it.
You've seen the commercials, right? They paint this picture of a perfect world where our digital lives and our real lives just merge. A future with holographic phone calls and this idea of an internet of senses where we could literally touch, taste, and smell things digitally. And honestly, it sounds pretty amazing.
But, what's the catch? Behind that shiny, polished vision, the story is always a little more complicated. What happens when all that marketing hype meets the messy reality of the real world? What are the hidden costs of living on that bleeding edge?
And you know what? We don't even have to look that far into the future to find out. We can start with the super advanced hardware we have in our hands right now, like foldable phones. They really are a glimpse of what's coming next, but man, do they reveal some harsh truths.
So check this out. This data comes from a user study about the Galaxy Fold, and it shows that this really cool, innovative design has a major Achilles heel, that inner screen protector. The moment that thing starts to peel, the odds of serious problems just go through the roof. For example, the chance you'll need an RMA, which is basically having to send your phone back for repair, it jumps from about 11% to over 37%.
And we're not just talking about a little cosmetic flaw here. A peeling protector makes it almost 4 times more likely that you'll end up with micro cracks on that beautiful main display. It really just highlights this massive gap between the promise of a revolutionary device and the fragile, sometimes frustrating reality for the people who buy it first.
Okay, so fragile hardware is one thing, but what happens when the technology becomes even more personal? When it's not something you hold in your hand, but something you wear on your face? Something designed to be, well, almost invisible.
So I want you to imagine something with me. This scenario comes from a fascinating academic paper. Picture it. You're a teacher, it's a few years from now, and you're in a totally normal parent-teacher meeting. Everything feels routine.
But then the conversation gets a little heated. And what you don't know is that this private, professional interaction is no longer private at all.
Because that parent sitting right across from you is wearing what look like totally normal glasses, but they're not. They are broadcasting your every word, your every facial expression to thousands of their followers online live.
And just like that, before you can even process what happened, you're a viral moment. You've become a spectacle for a global audience to judge, and you never even knew they were watching. This isn't science fiction. It's a very real possibility that our current social rules are just not ready for. And that's what makes smart glasses a whole different ballgame. The paper nails it when it calls them a phone on your face. It's not just about the camera or the microphone. It's about the disguise. It's about embedding that surveillance capability into an object that we're all conditioned to ignore.
And this gets us to the absolute core of the problem. This new wave of tech creates challenges that our existing rules and regulations just weren't designed to handle. There's this huge, gaping hole between what the technology can do and what our policies are even capable of seeing.
This slide just lays it out perfectly. Our school policies, for instance, are written for visible devices, phones, tablets. They're trying to deal with stuff like distraction or cyberbullying. They're completely unequipped to handle covert live streaming from a device that's indistinguishable from a regular pair of glasses. It's a total blind spot. The researchers have this really powerful name for what fills these gaps in our rules: spectral presences. It's this idea that, in the absence of explicit regulations, the influence of tech companies just kind of operates in the shadows, shaping our world and setting the rules of engagement without any real public discussion.
I mean, the paper puts it so well, saying this failure to address smart glasses permits the spectral presence of big tech to essentially set up shop in our schools. It's like we've left the front door wide open, simply because we didn't even realize we needed a new kind of lock.
So if the hardware is still a bit fragile and our social rules are totally unprepared, you might be wondering, why are we pushing ahead so fast? Well, it's because devices like smart glasses are just the tip of the iceberg. They're a key part of a much bigger vision that requires a whole new kind of digital infrastructure, the 6G world. According to the industry heavyweights, this is the roadmap. We start with the 2D video calls we all use today. Then we move into 3D augmented communication. By around 2030, the goal is full holographic communication. And after that, the whole shebang, a full sensory communication experience.
And what does that actually mean in the real world? Well, we're talking about networks powerful enough to support that Internet of Senses. Digital taste, touch, smell. It means connected, intelligent robots collaborating with each other, a smarter, more sustainable world with things like precision agriculture, and even creating fully digitized replicas of entire cities.
But the amount of data needed for this is just staggering. A single holographic call might need a gigabit per second. Powering an interactive digital twin of a city? Way more. This isn't just a simple upgrade, it is a fundamental revolution in what our networks need to be able to do. And this entire mind-bending revolution depends on one crucial, invisible resource. It's the absolute foundation of our digital future, and right now, there is a global hunt underway to find more of it.
That resource is spectrum. The best way to think about it is as a set of invisible highways that all our wireless data travels on. And if you want more data to move faster, it's really simple. You need more highways, and you need wider highways.
And this chart from Ericsson's Big 6G report lays the problem out in stark terms. To make that 6G vision happen, we need about 3 gigahertz of what's called mid-band spectrum. It's the sweet spot. It delivers both speed and coverage. But just look at what we actually have available today and what we might have by 2030. We are facing a massive shortfall.
So here's the bottom line. Even with the most optimistic projections, we are looking at a spectrum shortfall of somewhere between 1.5 and 2.2 gigahertz. Without those new digital highways, the traffic for our 6G future literally has nowhere to go. And that whole incredible vision, it remains just that, a vision. Which leaves us with a really fundamental question, doesn't it? We have this incredible, ambitious vision for a seamless, connected future. We're building the devices, we're dreaming up the applications, but are we paying nearly enough attention to the physical, social, and infrastructural foundations we need to actually build it on?